We'll aim for about 5 minutes on this. Question 3, the copier did some wonderful things with this light gray where you can't really see anything, so that's what question 3 looks like.
I assume for Q3, one of the answers of it doesn't print well is already taken.
Yeah, I mean, feel free to throw it in there, but try to come up with another one too. Okay, about another minute. Okay, so let's go ahead and we'll go over it, and I'll have you guys kind of self-grade, and then hand them in to me, and then I'll look at them after that. But let's just start with the first one. So, provide an example to explain the meaning human perception is biased. Anybody have something good for that? Okay. Yeah, okay. So that's a good one. That's the visual versus the auditory cues being mixed.
I put we try and make assumptions based on our experiences and the context of the situation.
Okay, yeah, that's another good one. Anybody, anything different?
I thought we focus more on something that's on the web page if it's
Yeah, okay.
Or like how we'll superimpose patterns into objects and all that in order to, perceive it as uniform or something like that.
Right, we're always looking for a pattern, always trying to make it fit. So I mean, pretty much for this one, and if you guys are unsure of how well you did or you don't want to give yourself a score, you can write a question mark in the score and I'll do it for you. But I think all of you will probably be able to do this. But the main thing we're looking for is that human perception is biased by kind of the past experiences we have, the fact that we're set up to recognize patterns, the things that we're used to seeing, that we're optimized for seeing, anything like that will count as a good answer for that. Okay, so question 2, I've got some of the Gestalt principles, so I'm just going to go through them so we can see them up here on the screen. So the first one, proximity. So that one's just the items that are closer, up here grouped. And it's fine pretty much on any questions, any quizzes or exams that we do. If you want to draw a picture to illustrate something, if you want to write words, whatever you want to do is fine. So if you drew something to represent that or wrote something like that, that's a good example of proximity. How many people chose proximity? Okay, so that's popular. Yeah. All right, continuity, it ran away from me again. There it is. Anybody choose continuity? Okay. So continuity being that, we assume that this bottom part exists even though we can't see it. Closure. Anybody choose closure? No one likes closure. But closure is simple enough, right? We're trying to make like a closed object, even though there are no triangles in this image at all. We can see quite a few of them by the combination of the edges. Symmetry. Anybody choose symmetry? Okay, a few chose symmetry. Basically, we try to see symmetry where we can. We try to make things as simple as possible. Seeing this as 2 diamonds rather than a segment and then an angled segment and kind of the components.
I have a question on the previous slide.
Yeah.
How much is us seeing the triangles and how much of it is being forced on us with, kind of like preconceiving you to see this due to structure?
Yeah. This is specifically as an interesting example. Remember the name of it. I'll look and I'll pull the original stuff on it to tell you about this one more. But it's both a top-down and a bottom-up processing that it's leveraging here. And I mean, obviously the strong contrast differences are doing that. But yeah, there's actually some good research on specifically this image. So I'll see if I can dig that out and tell you more about it. And common fate. Anybody choose common fate? Okay. So, you know, things that look like they're together are probably going in the same direction. Okay, so last one. What's problematic about the visualization?
Contrast to make it different.
Okay. Anybody got anything else?
I think there wasn't a lot of information, so you don't really know what it's about.
Right. Can anybody tell me what percentage is in January and what percentage is in February?
17 or something in January. Wait, I don't know. Is that the same color?
Yeah. So they're the same color. They're actually two different colors, but when you print them out, you know, in gray, or if you were to look at them without the color vision, they're kind of get mixed up. So the point there is you could either, you know, if you wanted to improve it, maybe you add like a pattern to one of them and add that on the legend or something. You could simply, you know, make the contrast better, or have like annotations where, you know, January's pointing to whatever it's indicating. But mostly what I'm looking for there is, you know, it's kind of ambiguous as to what this means right now, and so I used color and it didn't work. So point mostly is to be careful with using color. Okay. Anybody have any questions or anything? So we're going to say this is worth 3 points. So, you know, give yourself a score between 0 and 3 in the box there, or a question mark if you don't feel comfortable evaluating yourself. And then if you'll just pass them all down, I'll pick them up. I do like to read, you know, the answers you write.
Oh, wait.
I do actually have a question that may or may not have been helpful for number one. When someone's colorblind,
Yeah.
is their vision of a color going to be a sensation or is it going to be a perception? Because it's within the eye.
Yeah.
So which one is that?
It's a missing sensation.
Okay.
I guess there's definitely a perceptual aspect, because if you look at like non-humans, like birds, for example, they have 4 different color receptors, and so they have a different perceptual way of processing that. But yeah, I mean, personally, I think it's mostly a sensation deficit because you don't have a sensor. But I think it could go either way.
Jealous? There should be artists.
Okay, so last time I said we would look at past project examples, and so I pulled up the projects that I did several years ago in a version of this class, and unfortunately it was all in PDF and it was on Google Docs, and I did not own the Google Docs, so all I have are these PDFs of it. So we're going to try to go through that together. And let me jump out of this extended monitor real quick. Oh, that is annoying. Okay, that kind of works. I'm really curious what Camtasia is recording right now, but we'll find out. Okay, so this was a FedEx project. It's task code entry, and I honestly do not remember much about it, so I will be experiencing this with you, as I purposely did not review it ahead of time. So it looks like and this is, I should say, this is the first presentation that we did for like checkpoint 1 with FedEx. So like you guys, they had given us kind of that little slideshow of what they wanted, and this is the first presentation we did for them. So the general idea was that they need to enter these task codes as they do jobs throughout the day. It's kind of like just tracking their activities, if I remember correctly. And so here's, just the assumptions and requirements that they gave us. Basically, they want automatic time stamping, start and end work, and then some restrictions on, entering it in the different time ranges. And looks like we made like a nice little, very simple flow chart, just of kind of what the employee's process would be. They log in for the day, and I think that was FedEx has like a system they already use for people to log in and kind of clock in, and so they wanted to connect that to it, and then once you had clocked in, then you could start logging tasks basically. And so they were doing this with paper forms, which is wonderful. And so then let's see what we did. So they wanted it obviously on all the devices. Okay. So the main thing about the first checkpoint will be the sketches, just the preliminary kind of design ideas. So the way we presented this was each person in our group presented kind of their sketches individually, and that's what I think works best, and probably what you guys will want to do as well, just so everybody gets a chance to show what they've come up with, and FedEx has a chance to give feedback, because you guys will come up with different things and they'll like different things. And so you can see this one, Christopher, this is my group, he created his, and I think this is like a web-based mock-up tool or something. And so it's got just like kind of the elements already there. And so this is just roughly capturing some of this. Let me see if this zooms very well or not. Okay, yeah. So you can see a little bit closer. Kind of, it's got like a tabbed interface and basically start a task. You can edit tasks. There's some detailed input pages. This is their login. So some basic stuff like that. Okay, so here's the ones that I did. And I think, so mine I was trying to style more like, almost like tracking a package or something. And then we had some, just some other concepts of like having kind of this 3D skewed thing that could rotate. And then just like some analytics here. But real basic. So, none of this is super detailed. It's just literally just rectangles of different shades of gray and some text on them. I think I made this in Adobe's, what is it called? It's design something. Let's see, I think it's experience design. They're doing a thing right now. Yes, it's just XD. And I think it's free right now for everyone. It's like a beta thing. But this was whenever it first came out, so it was kind of cool because you can use it just on a tablet, and then it would actually like transfer it over to Photoshop, and it was all there if you wanted to play with it. But obviously you could do this in anything where you just make some shapes. And then yeah, so it's like some account info. I like to use names of people on TV shows when I do my interfaces, so that's Gossip Girl. So yeah, just like to see if people catch it or not. But FedEx didn't know about Gossip Girl. Okay, so this is another group member's sketches. These are kind of similar to the ones we saw Christopher done. It's a different utility though, so it's got a little bit of like a sketchy look to it. But overall, these are kind of the same thing, and so I won't bore you too much with going through. Hey, look, somebody left this screenshot in there. Huh. Okay, and then like here's something like very different. this was Lucas was in our group, and he was more focused on the mobile stuff. And so his sketches, you can see, are they're annotated. They're hand drawn for the most part, and he's focused a lot on the mobile side. And so I should say, you can definitely, like for this first presentation, do more hand sketch stuff if you want. It doesn't have to be like polished in a mock-up tool. For the second checkpoint, we definitely want it that way, but for the first one, that's fine. And so I think, yeah, each of us picked one to talk about specifically. So that will be the other challenge of this. That's good. I don't even know what the point of that slide is. And then there's your technical details. But the big challenge with presenting these things is that there are like 7 groups or whatever, and we have at most 2 days. And so you'd be surprised how quick the time goes when you're up there presenting. So kind of try to get everybody to have 1 or 2 things. Okay, so that was the first presentation. Okay, so this is the second one. Let's see if anything changed at all in here. You know, I don't remember. I think you'll see it's probably a combination of them in the end. I'll show you the working thing. Well, hopefully working. Okay, so that's all the same. Oh, here's some feedback. This is good. So I guess these are the things that they liked. I didn't see the emergency button. I remember that was like a legal issue or something. Like they didn't want us to track activities that could deal with an emergency. So you'll get weird things like that sometimes. They wanted more clicking versus typing because they were using touch devices, I think, in a lot of these areas. So this is the kind of feedback you'll get. And these look like the same thing. Okay, then we did a web prototype at this point, I guess. That is not online. But like, okay, so here's like the mobile prototype has progressed from the little hand-drawn thing. That's kind of interesting. Oh man, this calculates fuel cost. See, there's a little animation. That's kind of neat. Oh, hey, look, we made them all in a mobile version. And this looks like to me that this is like Bootstrap or something. So this is probably implemented in code already. Okay. Oh, and so good tip. So if, like in our case, I think we used something called Cloud9 or C9.io, which is like a collaborative web editing kind of thing. So everybody could code at the same time and see everybody else code. It's just like Google Docs, and then it has a server that deploys it automatically. So a lot of you will want to show kind of a live demo in class, but please have a backup. So these slides are the backup slides at the end that show you what the demo would show you if the demo didn't work. So. Yes, I think that's Christopher's cat. I don't know. Okay, so that was the second one. And then there's a third one here, but I don't remember 3 checkpoints, so. Let's see. Oh, we did get some more feedback. They wanted more color? Huh. Okay. So then at this point, for you guys, you will do this, well, it'll kind of be up to you. So you can either do it before checkpoint 2, or you can do it before the final presentation, but you'll have your implemented design, and then you'll recruit some of your friends and family to use it and give you feedback on like a short survey you'll design. And we'll spend some time talking about how to design that and how to make all of that work. So we incorporate that feedback. Oh yeah, look, there's the URL, c9users.io. Interesting. Okay, so that's all the same stuff we've seen. Okay. And let's see if the final has anything interesting in it. Oh no. Sorry, the resolution on this is very different at the moment. Okay, so that's the same stuff. So your final presentation will kind of include that first high-level summary again. FedEx likes this because they'll show it to other people from other departments that aren't familiar with the project. So it's nice to give them kind of just this short little intro. There's all those sketches. Web prototype. Oh, okay, look, there's the survey responses. So what did we ask? What is your overall reaction? Well, most people were satisfied, so that's good. Not sure what this is really measuring. Okay, so looks pretty good. Very good and good. And these, of course, so this is a very flawed way of, studying something if you're asking your friends and family about things like, is it good or not? Because they usually won't tell you that it's bad. So that's just a note if you're doing actual research. But for us, it's more about going through the exercise of it. Okay. I am not sure what that is even trying to get at there. Oh, people felt very positively. I'm not sure which member in our group wrote the survey questions, but okay. And then so I think we had people, could give comments. We'll talk about different ways you can do user surveys. So one interesting technique is called thinking aloud, and you get the person to just try to say their thoughts as they're using it. So that can be a lot of fun. In our case, I think this was just typing it in on the survey thing. Because we were just emailing out the link and letting people do it whenever it was convenient for them. Okay. And then, oh wow, looks like we're sucking up there a little bit. Yeah, so when you do your presentations, I'll give you some feedback too. So everyone will give you feedback, and you kind of pick what's the most important, what you think works the best. Obviously, FedEx's feedback is probably what you want to focus on. So, okay. So it was not running on the web, but I did pull it up locally. Let's see what it looks like. So this is kind of the final thing that we developed, and this will be interesting because I don't remember how to use it, but I think these up here, like the 48, 41, were they're shortcuts. These were really commonly used tasks. So if you click it, I think it fills it in automatically. And in this case, if it was a meeting, you needed to put in specific information about it. So that appears. Changing location, beginning a check ride. And then I think you can just, let's see, yeah, you can search. And so it's got that kind of thing. I don't know what a valid time really is, but then I think, okay, so then it adds that over there. And you can do this over and over. We've got kind of their previous time history things. And so none of this is connected to a database or anything, so the data is just kind of we have an initial set of data that always gets loaded, and then whatever we add in while we're interacting with it stays in the system. But that way it's easy to kind of reset it and get it back. And then as far as what we hand over to FedEx, let me see if I have. Okay. So there's the survey data. It's literally just, all of the files associated with index and index 2. I wonder which one was the final one. Oh, it looks like index. So literally we handed over just all of the code for that and then all of the design process. And so you'll want to do something similar to that. We'll look at it next week. We'll talk about the sketches specifically and what you need to do. And then we'll progress from there. But really the first checkpoint is just about sketches and showing them what you want to design. Okay, let me see if I can get us back to presentation mode. Okay. So last class we talked about sensation and perception, and since we went over most of that on the quiz, just real quickly show you some of the most frustrating aspects of that. We talked about kind of these things that we're optimized for, and those really stand out when you have these situations where those kind of come at odds with each other and create these illusions visually, or a combination of audio and visual. And then we talked a little bit about things being usable even when they're not in full color. And we talked about searching for things in a scene and how that's linear unless there's some contrast or something to make it stand out. And then we also talked about the fact that people really in the peripheral vision is not very high fidelity. It's good for motion, but for any details, not so much. Okay. Today we will look at cognition. It is really interesting because that slide does not have a black background over here, but it has one over here now. And so we're going to talk about this encompasses perception, but more kind of what happens in the brain and how cognitive psychology characterizes the brain and how it works in terms of memory and attention and perceiving things, as well as learning new things and then applying those things. So hey, our background's back. So what is cognition and how is it studied? So to give you just a little bit of cognitive psychology history, the cognitive revolution happened in about 1956. So psychology has this really crazy story going on. From about 1920 or 30 up until the 50s, behaviorism was this huge thing in psychology. And so the idea was that you could characterize everything that any person or animal did by stimulus response. Okay, so you could do these mappings for that. And pretty much anyone who said that that wasn't the case was, just ignored and shunned away. So everybody jumped on this behaviorist bandwagon, and we got a lot of great things out of behaviorism. If you've ever seen anything about like conditioning, like where a dog is trained to salivate at the sound of a bell, or classic things like that, that's all stimulus response. That's all behaviorism. And in fact, if you look in clinical psychology, so people are trying to overcome a problem in life, behavior therapy is very effective. So it works very well. There's a large part of human cognition that has these stimulus response roots, but it's not the complete story. And so to tell you where behaviorism really broke down, it couldn't explain language. And it really struggled with these higher level constructs that emerge. So it was great for showing, how someone habituates to a noise that keeps going off in their environment and isn't concerned with it after a while. But not so much why the sounds that we make in a certain pattern necessarily give us goals and intentions and that kind of thing. Could we represent all of that in a behavioral way? Probably. But it's hard to observe everything that we need to observe. So to give you an idea, kind of like some of the most detailed information we have, studies are done on organisms that have a measurable number of neurons. So like, 100, 300 neurons or something. And that's incredibly difficult, even when you can map each neuron and this organism can only do a few things. It's very complicated. And so behaviorism couldn't quite answer all of the questions. And so this cognitive revolution started, and basically this is kind of fortunate for us, most of us being computer scientists or interested in the field of computer science. the metaphor that cognitive psychology used and that they still mainly use today is a computer metaphor for the brain. And that's not accurate at all, really, but it's a convenient way to think about it. And so it's generally called an information processing model. There's a lot of work showing where that's lacking and it's not sufficient, but in general, it's a decent way to think about it. And so we'll look at the basic models and constructs that cognitive psychology has to offer and talk about kind of this information processing idea. So the brain being an information processor. So just to give you a little bit of insight about kind of the field of cognitive psychology, the thing that cognitive psychologists are most interested in is developing models to represent how the world works and how a person functions. And those models need to do two things. They need to explain what we observe, and they need to be able to predict what's going to happen. And if they fail to do either of those things, the models are no good and they need to be revised. They have to be testable, obviously. So the field of psychology started with a lot of what we would call armchair psychologists. And they actually did some great work. You'd be surprised what one guy could do alone, just sitting in a chair testing himself on memorizing letters and things. We don't want to discount their work too much, but a lot of things aren't so testable and are a lot more speculative. I think like one of the favorites for people to kind of hate on is Freud. A lot of Freud's theories about people and how they function or don't function are extreme, and they're all very speculative because Freud was a psychiatrist. He was treating a few patients, but by no means had a systematic way of analyzing these things or proving these things. So there's a big emphasis on things being testable. For an experimental cognitive psychologist, a lot of this looks like bringing people into a lab, into a very controlled environment, and focusing on a very narrow task. You don't want anything to confound that. There's also a principle of parsimony. So the simplest theory is the winner. It is the best explanation. You don't want a complicated theory. And if you have something that's complicated, the chances are that it's going to fail one of these explain or predict things pretty soon. So the danger is in having a theory that is either too broad or too fit to data that already exists. So if it's too well fit to things we've already seen, it's likely that it's not going to predict something accurately. And if it's kind of too vague, it's either going to fail to explain specifics or it's also going to fail to predict within any range of anything we care about. Cognitive psychology, the approaches and tools that are used are typically observations, so behavioral observations. A lot of tasks with timing people, seeing how many things somebody might remember if you give them a list of words, seeing how many they remember after 3 minutes, after 6 minutes, after kind of plotting things like that. Cognitive psychology gained a lot from being able to study patients with brain damage. So certain areas of the brain that people had either had injured or removed because early on to treat seizures and things, popular methods involved removing portions of the brain. And so that really provided us with a lot of insight into how the brain was functioning in terms of which areas were responsible for which things before we had any imaging technology to do that for us. Today, you'll mostly see, this will be in the area of cognitive neuroscience, which definitely overlaps with psychology. And you'll see mostly non-invasive imaging is done on the brain to kind of study what's going on. So okay, that should be fMRI. I will fix that. MRI, giant thing at the hospital that you get put inside of to scan and slice you up in 3D and visualize things. you can do a little bit different version of that. It's called a functional MRI, and it lets you see blood flow within the different areas of the brain. There are limits to this. It's limited in spatial resolution. You know, how many pixels do you really have? It's limited in temporal resolution. How many times can you image it, you know, per second? It's not a lot. And so there are some other technologies. EEG, the cap with all the little electrodes in it, is another way to look at different brain areas. FNIRS it looks like an EEG, but it's using infrared, and it gets you closer to kind of what you would get from a functional MRI. It's newer technology. It's still very expensive and not widely available. But all of these things are to image the brain. So a lot of research is focused on putting people in these imaging devices, having them do a task, and kind of looking at which areas of the brain are lighting up or where blood flow is going. So we get an idea of what areas are in play. And a lot can be learned from that and gained from that, but you should also be cautious about that. It's certainly a well-established and respected area of research, but it's not completely free of problems. And obviously, we only have so much resolution and so much ability right now. So those are some of the tools and a little bit of the history of cognitive psychology. It's a vast field and it's really interesting. So if you do have an interest in that, I recommend there's a textbook just called Cognition. It's probably the first one you would find. It's really good. There are lots of pirated versions on the internet just hanging out. So cognitive psychology is really interesting. If you get a chance, take a course in the cognitive or in the psych department here. Okay, so now I have a video because cognitive psychology has lots of good videos. So just get you to watch this. This is about selective attention.
This is a test of selective attention.
Count how many times the players wearing white pass the basketball. How many passes did you count?
Anybody count them?
The correct answer is 15 passes. But did you see the gorilla?
Anybody not see it? Yeah. Okay. So the first time I watched this, I did not see it, and it's, you know, once you've seen it, you can't unsee it. But this gets us right into the area of attention. And so the big question is, how do people decide what they're going to look at when there are a lot of things to look at? Attention, we should be careful. It's not necessarily implying consciousness or awareness. There's implicit attention given to things that you don't really realize you're giving, but it is there. What's important for us, I think, in terms of attention is that early on, people were really interested in kind of where's the bottleneck in attention. So they were looking to see if it was, you know, somewhere in the visual system, if it was in the auditory system. And that really, they did a ton of studies, having people attend to different visual stimuli and listen to things and try to balance all that out. And we learned a lot of things there, but the main thing that we learned is that there's really not a bottleneck. It's a capacity issue. There's so much of this resource and it's allocated. Whether that's through, you know, one sense or another, you only have a finite amount of it. So for us in HCI, the main thing is we shouldn't ask for attention that we don't need. And we'll talk more not just about attention in kind of this pure form, but attention in like a form of flow or someone being in a task and disrupting that and how harmful that is. So we really want to facilitate what the user's doing, the goal. So for example, when you play a video game and you're using an input device, you really don't think about that for the most part. That's just a seamless part of the experience. You're thinking about what you want to happen on screen. Similar way, we use a trackpad or a mouse, something like that. That's requiring a lot less cognitive resources from us. And so with your software interfaces and with hardware, but with, in our case, software, we don't want the user to think about our software or our interface. We want them to think about what they're doing. And so if our interface is demanding their attention just for the sake of being an interface, they're going to have a worse time than they would if it didn't do that. I've got another video to show you just because change blindness is a very humorous thing. But I'll kind of, before we watch it, I'll hit on the point about HCI. When things change in an interface, like if you need to notify someone about something or update a number or a value, you have to be sure to draw attention to that if it's important. And even if it means not necessarily like disrupting the user in that moment, but maybe like next to it you put like last updated, 10 minutes ago or something, and you put that in a different color or in something that's fading, so that when they focus back out on the interface, they know something's changed. And I'm speaking kind of vaguely. It's hard to say without the specific domain, but there are a lot of things like this where things will change in real time while a user's doing something else. And in the best case, they're slightly annoyed that they missed it, and it causes them a little trouble. And in the worst case, something slams into the ground and a bunch of people die because they didn't attend to it. And we'll talk about HCI disasters in one lecture in the future, which is also very fun. But for now, I'm going to show you this change blindness video, which is one of my favorites. This is not the original academic researchers, so this is done by a television program, but they did a really good Okay. So, good psychology makes for good TV. That is probably one of the most enjoyable studies to watch. So I'll tell you, in the real version of the study, about 50% of the time people noticed. And obviously they didn't show you any of the problems there. But the reason people are attending to something else, right? They're attending to trying to give somebody directions. It's someone they're not familiar with already. And the change happens quick and smoothly enough that if they didn't notice anything distinctive about the person, they don't attend to that change. And so, it's a leap from that to interfaces, but it's a similar concept. So to tell you a little bit about the bottleneck theories that were never fully resolved, these theories are at different levels as to they're trying to determine where the capacity bottleneck is. Is it at kind of the sensation lower level where you're being flooded with data coming in, or is it at a higher level where you're trying to cognitively make sense of that data? And no one really could show either way. They could kind of show both ways. And a capacity theory explained it a lot better. So let's talk a little bit about what's called working memory. So psychologists in general divide up kind of humans' memory into two categories. We have what we call today working memory. Sometimes people synonymously say short-term memory. That's slightly different. It's a little bit narrower in scope as to what it includes. But we have working memory and we have long-term memory. So working memory is a concept that's evolved with cognitive psychology. So this is one model. And kind of the idea is that you have basically some really short-term storage happening where sensory data is coming in. Kind of like, you've got like a buffer of the frame that you're seeing. And from there, you've got some perceptions about that scene that you're keeping in your active working memory. This area of memory is finite. It can only hold so many things. It can only maintain them for so long without actively reminding itself about them. So if I gave you an arbitrary string of numbers to remember, you could probably remember it if you would just repeat it to yourself over and over until I ask you for it again. But if I gave you that string of numbers and then ask you to do some math problems, you probably wouldn't be able to keep rehearsing it, and it wouldn't commit to what we consider long-term memory. So this is one of the first models. Sensory memory is considered kind of just this really low level, maybe like sensing the edges of the table or something. Not quite like just pixels on a screen, but really low level representations. Short-term memory at this point is just like saying, oh, that's a table and I'm in a classroom, that kind of thing. Short-term memory evolves though. And actually this diagram does have the arrow going back and forth here. So long-term memory impacts what's happening in working memory. So your past experiences, kind of how you're primed for a situation, like you're expecting only a certain subset of things to happen in this room, and it's probably a different subset than when you're at home or something. And that kind of works its way into short-term memory. So if we're going to the computer model, this is a little bit closer to this computer model. We can think of it as like having things in RAM or in memory versus out on a storage disk. And you've only got so much working memory. This is a slightly different representation of this. Basically, this kind of splits it into phonological, so just sound, then visuospatial, which is visual things, and then episodic is really pulling from your past experiences. So just to show you some of the types of results that come from work on dealing with memory. So this is asking someone to recall something, and this is like as the delay, the gap expands, and so you kind of see this exponential decrease in their ability to recall the string of numbers that they're memorizing. This is a really interesting effect that we get here, and this is called primacy and recency. And the idea is basically you're more likely to remember, if I give you a list of things, the first things I say and the last things I say, and not so much what's in the middle. And we can manipulate that and influence that by making some of the things I say related to one another and some of them not. And there are a lot of great illustrations of that in cognitive psychology. We don't have time to really do too many of those. But you can see that here, where these first few items are getting high recall, and the last few definitely, but in the middle you kind of get this. So working memory. The main thing for HCI is that it's limited. So this is a bad idea. Windows did this at some point in its life, and I'm sure it's still doing bad things, but this would happen when there was a connection problem with a wireless network. And it gives you the instructions on what you're going to need to do. But what's the first thing you have to do any of this? And then this goes away. So you've asked the user to remember all of this, and they're not going to, and it's going to be horrible. Another more subtle effect of this, so when you run a search, the term that you search for shows up there, right? This was me earlier today. But and that seems kind of like, okay, no big deal. But if you've ever used a system to search and it doesn't show the term you searched for in the next page, you will find yourself at some point wondering what you searched for and running that same query again because you don't know. And so like obviously a high-level first search like this, you probably won't forget. But as you dig more and more into a subject and you're running more queries, you really need to be able to see what the thing is that you're looking at results for. So, working memory, we're going to kind of conceptualize as this information processing system. It's more a workspace, a workbench, than like a warehouse of storage, okay? So the important thing is that it's very active. Things are coming in and out, and if there's not some process keeping it active, and usually that's attention, that you're focusing on something, then that thing is going to disappear from the short-term memory. So limited capacity in space and time. Right now, I think research shows 5 things is the average that a person can keep in short-term or in working memory. But that varies by person, and it varies by the thing that you're trying to keep in there. For HCI, we want to keep that as free as possible. And we want to provide the user with like the most helpful information we can give them without taking too much of their attention. So this is a trade-off, and it's pitted against each other. So I'm sure you've probably at some point run an update on something or signed into some app or service for the first time, and it wants to give you a guided tour, and it will not give up. Like it's blocked everything, and it's just highlighting, and it's like, this button is for whatever. That's a balancing act. Obviously, I'm talking about an experience that was not pleasant for me. But you can do it in a way that's not necessarily disruptive. And you can do things like when you make a big change, point them out, but make it easy for a user to get rid of those things. Briefly, we'll touch on long-term memory. It's not incredibly important to us in this course and within the HCI that we'll be doing. But I'd like to give you an idea of it. Basically, kind of break it into 3 categories right now. Episodic, semantic, and procedural. Procedural is like riding a bike, tying your shoes, things that you do that you might consider muscle memory. They are little auto routines that you can call up and run at any time. You don't really have to consciously think about it, much more than just having the goal of doing it and being able to make it happen. What happens is that pulls up something from long memory, puts it into working memory, executes the plan, and you go. Semantic memory is all about what things mean. This is about your experiences. This is what develops, I guess, when you're a child mostly, and you start to learn about the world and what objects are and what they do, and just facts about the world that you're going to operate in. Episodic memory is where we find like autobiographical memory, things that happen to you. So you can tell stories about an experience that you had, and you can kind of put yourself back there, and you can relay that information out to the world. One thing that's really important: retrieval alters memory, and that's just how it works. So for a human, when we recall something, and it's not, I should say, when it's procedural or something like that, where it's a practice over and over, that doesn't get altered because you're practicing it and you're getting feedback from your environment. If you were to try to tie your shoe in a way that you couldn't actually do it, you would quickly be guided back to something that worked. But episodic memory specifically. So we see this being a big issue when people are eyewitnesses to crimes. We see this kind of being really interesting. People will remember aspects of their childhood that we know they couldn't possibly remember, but they have, someone has told them about it, they've seen photos of it, and they've now put that into their long-term memory and can't distinguish from it. And stories change kind of as people tell them. Details get lost, they get touched up. That's how our long-term memory works, and that's a really good thing. We don't have time to get into it, but if you're in clinical psychology and you're studying something like post-traumatic stress disorder, a lot of what we believe about how that works now is the process of taking your experiences and encoding those into long-term memory. There are very promising treatments for post-traumatic stress disorder that involve having a person relive the trauma and then disrupting the process of re-encoding that. And so it's incredibly interesting. And you can disrupt that process a number of ways. One of the most interesting ways is rapid eye movement, which just sounds insane. And the person who came up with it didn't really come up with it for scientific reasons, but it was working. And people who were studying it in a scientific way were realizing it's working. And it turns out that it was disrupting the way that things were encoded into long-term memory. You can do this with drugs. Drugs like ketamine are being investigated pretty heavily now. That's typically like a party drug, but it's useful for treating things like PTSD and depression in conjunction with therapies. So the fact that memory works this way is a good thing, but it's also a difficult thing at times when we're talking about witnessing crimes or things like that. For HCI, don't ever depend on long-term memory. Best case, you'll get somebody with procedural knowledge. So like those of us, if we use like a terminal a lot and type commands in, there are commands we just know. That's procedural for us. But like when you first start to learn that, it's not procedural, and it's a lot of looking back and depending on long-term memory and trying to form that. Example one of the books gave is like forcing users to choose from security questions rather than letting them make their own. So, and that is difficult because sometimes the choices and you just don't remember. I just put arbitrary answers into a password manager, but that's probably not the average experience. Another thing that's really interesting, encoding matters a lot. So, for example, if you study for a test while you're high on marijuana, you should definitely get high before you take the test. Because the context that you learned in needs to be the same as the context that you test in. That's an extreme example and probably one of the more interesting ones that's been studied, but also just the room that you're in. So if we were to have our test, in some other classroom that was very different from this, that might have an effect. It would probably be a small effect, but actually, I had a professor. He did research having people learn things scuba diving underwater and then testing them either underwater or on land, and there was an effect on that. So this is about episodic memory. So this is looking at people retelling what they remember about September 11th. And we do see that in general, episodic memory and non-episodic memory both start to decay over time in consistency. So that's just something to remember. So I'll wrap us up on this slide, and then we'll pick back up next time here. But basically, there are easy things that we have, and that's procedural things typically. Riding a bike, driving. A lot of us, we can drive places and we don't even realize we did it. And that's kind of scary, but it's also fine because these things just auto run. But there are things that are not as easy, and those are things like, navigating somewhere that you're not familiar with, or following a new recipe. Trying to write with your other hand, you should do that. Switch from Mac to Windows. I challenge everyone to do that. Whichever one you're on, switch to the other and see how it goes. You should use them both. But we'll stop there. When we come back on Tuesday, we will talk about dual processing theory, and it's really fun. So I encourage you to be here on Tuesday.